Alright, we're going to learn another method to solve these integrals in which the derivatives are formed by the chain rule, and the method is going to be what we call substitution. And over here what I've done is I've written 6 steps that you can go through and use substitution. And what I'm going to do first here is I'm going to look inside these parentheses. I'm going to let u equal what's inside those parentheses, and it's going to be x squared plus 4. And then I'm going to take the derivative with respect to x, so I'm going to have du dx is equal to 2x. And then I'm going to solve for du, and du is going to be 2x dx. So wherever I see 2x dx, I can replace it with du. And so right here I see 2x dx, I'm going to have a du right here. This x squared plus 4 I already said is going to be u, so I'm going to have u to the 1/2 power, or 1/3 power, sorry. And then I've got 1/2 as my coefficient, and this is what I'm going to integrate. So I'm going to look at that exponent, add 1 to it, so I'm going to get u to the 4/3, and I have 1/2, and I'm going to multiply with the reciprocal, which is 3/4 plus c. So I'm going to get, that's going to be the same as 3/8 u to the 4/3 plus c, which is the same as 3/8 times x squared plus 4 to the 4/3 power plus c. Alright, so I'm going to do the same thing here. Again, here's what's inside my parentheses. So I have x squared plus 4 is equal to u. 2x equals du dx. That means 2x dx equals du. So now I can rewrite that as integral u squared 2x dx is going to be du. So I have very simple integration problems. I'm going to have 1/3 u cubed plus c, which gives me 1/3 times x squared plus 4 raised to the 3rd power plus c. Alright, I'm going to do the same thing here. Here's inside my parentheses. U equals 1 minus 2x squared du dx is equal to a negative 4x. Du is equal to a negative 4x dx, which is what I have right here. So now I'm going to integrate u to the 3rd du, which gives me 1/4 u to the 4th plus c, which is equal to 1/4 parentheses 1 minus 2x squared to the 4th plus c. Alright, and you can see, and I'll check it here, I'm going to take the derivative, I'm going to check by differentiating. 4 times 1/4 is 1, and I'd have 1 minus 2x squared to the 3rd, the c would be gone, times a negative 4x, and which is what I would have right there. This one right here, here's my parentheses. So I'm going to let u equal 5x. So du dx is equal to 5, or du is equal to 5 dx. Now here's my 5 and here's my dx, so once these are gone I can replace du in there. So I'm going to integrate cosine of u du, because once I substitute, that's what I'm left with. The antiderivative of cosine is sine of u plus c, which is the sine of 5x plus c. Next, again, I'm going to let u equal 4x squared plus 3 du dx is equal to 8x. So that means du is equal to 8x dx. Now I don't have an 8 up here, but I do have an x and a dx. So what I can do is multiply both sides by the reciprocal of 8, which is 1/8. And 1/8 du is equal to x dx. So now I'm going to integrate. I got 1/8, and u is going to be u to the second power, because u is 4x squared plus 3 du, and that's going to give me u to the third. Here's my 1/3. I'm multiplying by 1/8 plus c, and so it's going to be 1 over 24 parentheses 4x squared plus 3 to the third power plus c. Alright, this next one I'm going to rewrite, number 12, as x times parentheses 2x minus 1 to the 1/2 power dx. And if I let u equal 2x minus 1, that means du dx will equal 2, and that means du, let me kind of put a separation right here so we don't get confused. Du equals 2 dx. So I look, I have a dx, I don't have a 2 dx, so I can write 1/2 du equals dx. Alright, so wherever I see dx, I can put 1/2 du in. And so now when I substitute, I don't have anything in terms of x. I have u to the 1/2 power, and for dx I have 1/2 du. So I have everything but this particular one in terms of u, and what I can do here is I can take this equation and solve for x. So I have u plus 1 equals 2x, or 1/2 times the quantity u plus 1 is equal to x. So that's going to give me 1/2 u plus 1 times, this is all times, u to the 1/2 power times 1/2 du. Okay, I can rewrite this. I have 1/2 times 1/2 times u to the 1/2 times u plus 1 du. Well, 1/2 and 1/2 is 1/4, so I have 1/4 integrate u. Now I'm going to distribute this. I'm going to take u to the 1/2 times u to the first. You add the exponent, so it's going to be u to the 3/2 plus u to the 1/2 du. My halves and my 3/2 are a little icky. So now I'm going to have 1/4 times, okay, I got u, I'm going to add 1 to that, I'm going to get 5/2, multiply with the reciprocal is 2/5, plus u, this is 1/2, I add 1 to that, I'll get 3/2. Again, I have 1/4 because that 1/4 is being distributed through the entire integral. And over here I have 2/3. So, plus c. I'm going to write that up here where I have a lot of space and you can see it a little bit better. 1/4 times 2/5 is 1/10. I'll get rid of the u because that is 2x minus 1. And it's going to be to the 5/2 power. I think it'll be easier to see. Plus 1/4 times 2/3 is 1/6. 2x minus 1 to the 3/2 power plus c.